Hello everyone and welcome back. I am Mr. Cobalt, and in this video I am going to do my second problem involving the average atomic mass. Now this one is less straightforward, but if you remember from the last couple of videos, to when you're trying to figure out the average atomic mass, you have a formula that you can use. Remember, the average atomic mass is going to be the fractional abundance of one element or one isotope multiplied by its mass plus the fractional abundance of another isotope multiplied by its mass, and so on for all of your isotopes. Now, in this case, in this problem, the last problem we worked on, it was asking straightforward for what is the average atomic mass of copper. And they gave us the percent abundances and they gave us the masses. So we just plugged it into the equation and we got the answer. This problem, a little bit different. So let's go ahead and read this problem. So problem number 2. Gallium has two naturally occurring isotopes. So again, we have two isotopes. Gallium-69 with a mass of 68.9256 AMU and a naturally occurring abundance of 60.11%. So that's our first isotope. They gave us the mass. They gave us the mass of the isotope and the percent abundance. And then the other isotope is gallium-71. That's all they give us. Gallium-71. No mass, no percent abundance. And then they say use the atomic mass of gallium from the periodic table to find the mass of gallium-71. Okay, so we get to use the mass, get to use the atomic mass from the periodic table. So let's write out the equation. So the atomic mass is going to be equal to the percent abundance, or the fractional, let's say fraction, of isotope number 1 multiplied by the mass of isotope number 1 plus the fraction or fractional abundance of isotope number 2 multiplied by the mass of isotope number 2. Okay? So we'll say that isotope number 1 is going to be gallium-69. So this is going to be Ga69. This will be Ga69. And then number 2 will be 71. So we have Ga71 and Ga71. Okay, so they're telling us to use the atomic mass from the periodic table for gallium. So let's go ahead and look that up. So we have, where is gallium? There you are, 6972. So 6972 AMU from the periodic table. That's the atomic mass. And they're asking for the mass of gallium. Find the mass of gallium-71. So we need to find this. So this is going to be our X, right? So mass of gallium-71. So that's what we're looking for. They gave us the percent abundance. We can turn that again into a fractional abundance by dividing out of 100. So we assume 100 atoms. So the fraction of 100 atoms that has that mass of 68.9256 is going to be 60.11. So 60.11 divided by 100. So that's our fractional amount. And we're going to multiply that by the mass of that isotope. So 68, that's the mass, 68.9256 AMU. Okay? And then we got this plus, we got to have our plus. And so this is what we're looking for, but they didn't give us the fractional abundance, or in this case, the percent abundance of our other isotope. So how are we supposed to solve this when we have two unknowns? Do we have two unknowns? how could we find the fractional abundance, or at least the percent abundance of this isotope? Well, they say there's only 2 naturally occurring isotopes. So if I already know the other percent abundance of the one isotope, then if there's only 100% total and there's only 2, then it's out of 100%. So I'm just going to subtract 60.11 from 100, and that'll give me the percent abundance of the other isotope of gallium-71. So 60.11, subtract that from 100, that's going to be, let's see, that's going to be 39.89, right? So 39.89%, right? So that's going to be out of 100, so I'm going to divide that by 100. So now I have one equation, one unknown. So now all I do is I solve this equation for the unknown. So let's go ahead and solve this. So I'm going to multiply and divide that together. Let's see. So that's going to be 60.11 divided by 100 multiplied by 68.9256 equals, that's going to be 41. So this is going to be 41.4311 AMUs plus, and that's going to be 0.3989 multiplied by the mass of gallium-71. Then I'm going to subtract both sides, 41.4311 AMUs. Subtract that, 41.43 AMUs, or 40.11 AMUs. So I'm going to take 69.72, subtracting out the answer equals, and that's going to be 28. That's going to give me 28.2888. Okay? AMUs. And that's going to be equal to 0.3989 times the mass of gallium-71. And now finally, all I have to do is divide this by 0.3989 equals, and I get a mass for the mass of gallium-71 is going to be 70.917. Oops. 70. So that's going to be 70.917 AMUs. And again, we would make sure that we're looking at our sig figs and making sure that we're doing everything right. So go back here. So we multiplied and divided. So that means least number of sig figs is going to be 4. So we're only allowed up to here. So for this one, again, 4. So we're only allowed up to there. So now we're going to subtract. So when you're subtracting, it's the least number of decimal places. So here, this is what we found in our table. So we are giving up to the 2, the second decimal place. And here, if we're subtracting, we're only allowed up to the second decimal place. So when we add these, or subtract these, then we're only allowed up to the second decimal place. So that's what we're allowed to here. And then when we divide, we're back to division. And again, when you divide and multiply, your answer can only be in the least number of significant figures. So here we have 1, 2, 3, 4. We have to stop at the 8 because we're only allowed up to the first 8. So that's 4. And then this is 4. So the least number is 4. So that means we're only allowed up to the 1. So then we have to round this to a 2. So we drop the 7. And so the final answer is going to be 70.92 AMUs. And so that is the mass of gallium 71. And you can see that it's very, very close to 71. Okay, I hope this was helpful. Again, if you know the equation, then basically you're just making sure that you plug everything into the equation that you know and solve for the unknown part. I hope this was helpful. Let me know in the comment sections if you have any questions. Make a comment in the comment section. Share this video, like this video, subscribe to the channel, and ring the bell. Thanks for joining me, and I'll see you guys next time.